So, like any good chemist, organic chemists love to take shortcuts. And one of the shortcuts that they take is they will draw a molecule looking like this. All right. What they've done here is they have taken a shortcut, and so we sort of love them and hate them for this. But the shortcut is right here, right? You're not used to seeing just two bonds kind of coming together. We got a double bond over here. We got a single bond on this side. That's super freaking weird, right? Yeah, what there should be, right, is there should be an element, right, somewhere in between there. Well, what organic chemists do is they take a shortcut. They recognize that what's going to happen is because in organic chemistry you have a whole lot of carbons all the time, then what they do is they take a shortcut and they represent a carbon as merely a point on these lines. So what we've got right here is there's a carbon, and it's being bonded over on each side. So there's a double bond coming out of one side and a single bond coming out of another side. So that's a shortcut that they've taken there. And they're not just cutting out carbon, because we realize that carbon, if you look at the work from yesterday, carbon always forms 4 bonds. It's always got 4 lines coming out of it. This carbon, however, only has 3 lines coming out of it. So what we're going to do is we're going to recognize that coming out of that carbon, there is an understood to be a hydrogen there. What they do in organic chemistry is they say, hey, we recognize that carbon always has to have 4 bonds. So the 4th bond that we're leaving off of there is that bond to a hydrogen. So they are leaving out a carbon and a hydrogen whenever they draw things this way. Isn't that weird? So what we're going to do is we are going to take this molecule and we are going to draw it, right? So what I want you to do real quick is, if you need to pause it right now, you're welcome to pause it. You can pause it right now. Draw this in your notes. All right. Now that you have it drawn, and by the way, it doesn't need to look perfect, right? I have been doing chemistry for 20 years, and I cannot draw a perfect hexagon to save my life. I tell you what, that's as close as I can get. And look, that's not really even close to what we've got down here, all right? So yours doesn't have to look exactly like this. But the idea here is hopefully every line is correctly in place. So what we're going to do is we're going to go through, and the first thing we're going to do is we're going to identify everywhere where there is a carbon. So here we've got a single bond coming together. I've already drawn this one, so we're going to circle this one right here. I'm going to draw a big old dot right there where that carbon is. Big old dot right there where that carbon is. And you know what? You can make it even bigger if you want to. If you didn't draw yours quite this large, that's fine. Huge old dot. There's a huge old dot for that carbon. That carbon is bonded over on this side. It's got a double bond that goes to this area right here. And oh, look, there is another carbon for us in that spot right there. I could go down or I could go right. I'm going to go to the right. There's a carbon in this spot right here. See that line right there goes from that carbon up to that carbon, and this carbon is bonded down here to this carbon right here. So now we don't have to worry about putting a carbon here, because that bond is going from this carbon to this nitrogen. And what's really weird is that nitrogen also has a couple hydrogens attached to it. More on that here in just a minute. But let's go back. Let's keep counting carbons. So we got a carbon down here. And then we got a carbon down here. We got a carbon right here. We do not have a carbon right there because that one goes to oxygen. And we have a carbon right here. So how many carbons are being left out of this diagram? Well, we're going to write over here, we're going to write a big C, because we're going to write the formula for this thing. How many carbons are there in there? There's understood to be 1, 2, 3, 4, 5, 6, 7, 8. There are 8 carbons. This is C8. All right. Now the next thing we need to do is we need to go in and count hydrogens. And right now we can look at it and we see we've got 2 over here and we've got 2 over here. And you're like, okay, so we have only 4 hydrogens here. No. Remember, we already talked about this carbon. If you look coming out of that dot, there's 1 line going this way and 2 lines going that way. It only has 3 lines coming out of it. Every carbon needs 4 lines. So we're going to have to draw another line coming out of that carbon. And I'm going to remember that each line I draw, that's going up to a hydrogen. So right here, this carbon, the one right next to it, the next one that we drew, it has 1, 2, 3, 4 lines coming out of it. We don't need to draw any hydrogens on that carbon. It's all good. The next one I drew was this one right here. It only has 2 lines coming out of it, so it needs 2 hydrogens coming out of it. 1, 2. And this one's the same way, right? It's got 2 lines coming out of it, so we need 2 hydrogens on that one. Don't finish, right? Get all your carbons. Don't forget to come back and say, did I look at all the carbons? By the way, that's one reason I put a check mark on this one, to keep track of the fact that I know it's good. All right, coming out of this carbon, I got 1, 2, 3 lines, so I need a 4th. Right? You can have 4 lines each time. 1, 2, 3. Oh, need a 4th. This one right here, this carbon right here has 1, 2, 3, 4. It's all good. And this carbon right here, 1, 2, 3, 4. It's all good. Check. Now we count up the hydrogen. So we already had the big 4. There's 5, 6, 7, 8, 9, 10, 11. 4 plus 7 hydrogens that I drew in gives me 11 hydrogens total. So we're going to draw a big H. We're going to put an 11 on that guy. Then we're going to look, and the next element, we usually go in alphabetical order here, so nitrogen is one we're going to look at before oxygen. So how many nitrogens are there? Well, there's only 1. So we just put an N, and we put a 1 right here. No siree, Bob. It's understood to be a 1 there, so we don't have to worry about that. And as for the oxygens, there are 2 oxygens, so NO2. Now, what's really neat about this is we can take that formula and we can plug it into Google. So pull up a Google here. Oops. I can also move my face around. We're going to plug this into Google. I got to remember what I wrote down here. It's C8H11NO2. C8H11NO2. Oh, look, it's almost like I've Googled it before. That chemical is called dopamine. It's a chemical found in your brain. It's a chemical that they've linked, if you go and read a lot about it, it's a chemical that they've linked to some of the problems that occur in the brain during Alzheimer's, right? It's a lack of dopamine that's caused there. It's kind of fun. It's also got a lot of links to Parkinson's and things like that. So there, that chemical is dopamine. Much easier to draw it this way than to have all these carbons and all these hydrogens in there. A lot less in there to draw. I don't expect you to take the formula and draw it. That takes like 2 semesters of college-level organic chemistry. What I do want you to do is to look at a diagram and to be able to tell me what its formula will be. This one's a little bit tricky, but if you would like to pause it and try it out, I'm going to pause my video. I want you to draw it. I want you to try and count the number of carbons. And when you resume this, I will tell you the number of carbons. So if you identified your carbons correctly, you should have this many carbons. You should have 1, 2, 3, 4, 5, 6, 7, 8. This is C8. Now I need to go to each carbon and identify the number of hydrogens. You try it. So if you identified the number of hydrogens correctly, you're going to notice I took a quick shortcut here. I didn't even write hydrogen. I just knew from each line, right? Each line here means that there's supposed to be a bond to a hydrogen. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10 hydrogens for this. All right? Now the last part becomes pretty easy, and I hope you just went ahead and wrapped up the formula there. You got an N, right? Nitrogen comes next, and there are 4 of those, and oxygen comes next, and there are 2 of those. Pretty easy problem. Let's Google it. Let's see what you get. C8H10, C8H10N4O2. Like I Googled it before, that is caffeine. Caffeine. You see that one on a whole lot of coffee mugs. A whole lot of coffee mugs. You see it sometimes on t-shirts. Some people have it as tattoos. Pretty cool. We'll go ahead and name it right here, caffeine. All right, I got one more for you to try, and then you're ready to start in on your work. I do want to show you this one. It's a little bit weird. On this one, you see these things right here. These are called wedges. All you have to do with a wedge is it's just a bond is all it is. It's just a fancy way to draw a 3-dimensional bond. So when you're drawing this one, just draw that as a straight line, because we don't really care about the wedge thing in this level of chemistry. All right, this one's tricky. Give this one a try. So a lot of people get to this point and they count them up and they say 1, 2, 3, 4, 5, 6 carbons here, 7, 8, and they'll write down C8. But they forget about these 2 carbons right here. There's 1 carbon there and there's 1 carbon there. So this is not C8, it's C10. Oops. So when you're counting hydrogens, be extra careful that you don't make the same mistake, right? 1, 2, 3, 4, 5, 6, 7. But then don't forget to count the ones that are already there. 8, 9, 10, 11, 12, 13, 14, 15. This one is C10H15. Double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. H15. Great. All right. Last but not least, let's look at the last 2. There are only 2 other elements here. There's nitrogen, and there's only 1 of them, and there's oxygen, and there's only 1 of those. So if I did all of this correctly, C10H15NO, that compound is known as ephedrine. Here comes the ephedrine down here. And ephedrine used to be in a whole lot of different medicines, but they took it out because they found out that ephedrine, back in the 90s, they started removing it from chemicals because you can take ephedrine and make a really, really pure crystal meth out of it. So they stopped selling ephedrine in drugstores. Anyways, that's what organic molecules look like. That's how you interpret these. That's how you turn it from structure to formula. Now you're ready to practice on your own.